Hello everyone, and welcome to Jam Academy. The objective of this example is to help you to know how to calculate the automotive power delivered by the engine of a car. Now, in front of us we have an automobile whose mass is about 2300 kilograms. Suppose 10 horsepower are required to drive this car on a horizontal road at a speed of 75 kilometers per hour. We're asked to determine the total retarding force acting on the automobile. Now we need to start first by drawing our free body diagram on the car. The weight of the car obviously acts downwards. This is the traction force. This is the total resistive force acting on the car, and this is the normal force acting on the car. Bear with me that the power delivered by the engine of the car to the wheel is equal to the traction force multiplied by the velocity. This means that F is equal to P all divided by V. This expression gives us the traction force pulling the car forward. But what we know is that the car is moving with a constant velocity, which means that the sum of forces along the x direction is equal to 0. This would mean that the forces to the left will balance the forces to the right, which is just going to be equal to P over V. So the question is, what is P and what is V? Now, the power is given in terms of horsepower, so we have to convert that to watts. Now, V is given in terms of kilometers per hour, so we need to convert this to SI units. How do we do that? By the way, we know that 1 horsepower is equal to 746 watts. That's what we know. It's equal to 746 watts. And we also know that 1 meters per second is equal to 3.6 kilometers per hour. These are the conversion factors that we are going to use in this particular problem. Hence, the power, which is 10 horsepower, we will multiply that by 746 watts in 1 horsepower, and if we do that, this will be equal to 7460 watts. So that gives us the total wattage. That gives us the total power. Now, what about the speed? The speed V is equal to, it's given in kilometers, so we have to convert those to meters. This is 75 kilometers per hour. Now remember that in 1 kilometer we have 1000 meters. So we multiply that by that conversion factors. In 1 hour we have 3600 seconds. Now all we have to do is find out what the value of V is, and we can gladly calculate that together. So we have 75 multiplied by 1000, which will give us 75,000 divided by 3600. So the answer, the speed will be 20.83 meters per second. Hence, the total resistive force, FD, will be equal to 7460 watts divided by 20.83 meters per second, which implies that FD is equal to, let's do the calculation again together, 7460 divided by 20.83. That gives us 358.1 newtons. 358.1 newtons. So this is the total resistive force acting on the car. This gives us the total resistive force acting on the car. Well, thank you so much, fellas. I look forward to the next lesson, so please stay tuned. And if you have any question, ask in the discussion forum below this video. Thank you, and bye-bye.